Okay, in this video I'm going to be covering the Formula One car specifications. This document is located in Google Classroom. You don't have to print it, but I would definitely have it open so that you can follow along with these specifications as you design your working drawing. We're going to break this down into a few parts. This top row is body. You'll see there's body length, body thickness, and overall body height. We're then going to talk about the axles and the CO2 cartridge housing. We're then going to talk about what I refer to as the parts, which is the spoiler, front rear airfoil, side pod, and last but not least we'll refer to the wheels. When we speak about the body of the car, keep in mind a Formula One car is made up of parts. If we were to take this example here, here's a car with no wheels on it. Looking at this from above, you get a good idea as to what I mean by parts. These are two rear airfoils, these are two front airfoils, and here are two side pods glued to a car body. So this piece of the Formula One car, this is what everything gets attached to. This part of your car has its own set of specifications, just like the rear airfoil, front airfoil, and side pod have their own specifications. So we're going to be breaking this down into parts. So I'm going to focus on the car body to kind of give you an idea of what I mean by just the body of the vehicle. Here's a completed car. Here's just a car body. Obviously this one is not complete, but this is going to be my example when I refer to the specs that speak to only this part of your car. So once again, we're not referring to the parts that are glued onto it. We're referring more to the body of the vehicle when I talk about the specifications. Now, using this as an example, let me go ahead and get a little bit closer to the specifications. Let's start with the car body. So the body length, minimum 180, no more than 210. We will have discussed something called tolerance in class and or through Google Classroom, through Collaborate, but keep in mind tolerance does not come into play until we have actually started construction of the car. So your specifications are what you're following on the drawing. This is what comes into play when we are in construction mode. So 180 to 210 body length. So you're going to obviously need a ruler in order to complete this activity accurately. You have hopefully found a metric ruler around the house. And if you were not able to find any type of measuring device, I did post a paper version of a metric ruler. And this could actually be downloaded and printed. I would cut out this metric ruler. It's very accurate. It's just as good as having a real ruler in hand as you're measuring and designing your car body and parts. So this is an option. If you're able to print, you'll also find that the working drawing itself has a grid. The grid box that you see on this piece of paper, the boxes are each 5 millimeters by 5 millimeters. So this kind of becomes an easier way to make sure that your parts are being drawn to the right length, width, and height, parts and car body. So we have a few options for measurement. So once again, let's go back to the car body. We said this needs to be between 180 and 210. So I'm going to go ahead and place the car body down on the table. I'm going to grab my metric ruler. I'm going to place it like so. I'm going to zoom in here so we can kind of get a better sense of what's happening. This is once again measuring from the furthest point to the back to the furthest point forward on your car body. So as I lay this car flat on the table, I'm going to just give you an idea of what's happening right here. I know it's kind of hard to see my ruler, but if I line up my ruler at 0 on the back and I measure to the furthest point forward on the car body, this car measures about 183. That's a legal body length. Now, if I remove this example and show you a Formula One car that's been fully assembled, painted, all it needs is wheels and axles, I would once again be measuring from the back of the car body to the furthest point forward on the car body. Keep in mind, body, this, and this are not part of the specification. So this car here, along with this body here, both are legal. Let me go ahead and measure this one. I would actually measure this one a little bit differently for the demo, but if I were to measure from the furthest point to the back, all the way to the furthest point forward, I would more than likely find that this car is also legal. This was a car I used in one of my demonstrations. This car actually comes out to about 183 as well for the body length. Okay, now let's move on to another specification, body thickness. This is between the two axles, so we don't really know if we are or aren't meeting the spec until we know the location of the wheels and the axles. Let's just focus on front view. Front view says 15 millimeters is the minimum thickness of the car body between the wheels. Let me use this example here. So on any car, here's your rear axle, here's your front axle hole. When you're doing when you're measuring the specification, once again, it's the body, has nothing to do with the Sidepod, has nothing to do with the airfoils. You would need to find the thinnest part of your car body between the front and rear axles. So I could probably tell you right here's the thinnest part of this car body. And if I were to take my ruler and measure it, we can verify that this is a minimum of 15. Remember, we're not using tolerances. It needs to be 15 or more on a drawing, that is. And this car is coming in at exactly 15 millimeters. Now, if this car was 14, it would actually be legal now because the car has been constructed and painted. But since we're working on a drawing, the car must have a minimum thickness of 15 when we refer to the car body. Let me show you the other example I used earlier. We are once again to take this car body, just the body, and we were to once again find the thinnest part of the body between the rear and front axle. It would be thickest, thickest, thinner, 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 thinnest. This is the thinnest part of the car body between the front and back axle. So if I were to measure this once again, I'm going to get in a little bit closer here. I'm going to take my ruler. I'm going to measure this vertically. This car body here is about 16 millimeters, which once again means that this is a legal car body for that specification. This specification is actually very easy. Top view of a car body, 32 millimeters. Well, this is actually very simple because when I do give you your wood for this project, it actually is already 32 millimeters wide. So the body will already be 32 millimeters wide. Remember, it says maximum. So could we make the car body thinner? Yes, it could be less than 32 millimeters in width when we're looking at the car body from the top view perspective. So once again, it's already at 32, but it could be narrower in design if we chose to do that. Okay? Last but not least is the body height. Keep in mind that it says something about a spoiler, then it says something about the overall body width, and we're going to get into this next, okay? And there's also something about an internal cut. So let's first talk about the height. So when you are once again given this block of wood for construction, it's already 32 millimeters wide, it's already 210 millimeters long, and you got it, it's already 50 millimeters tall. So you couldn't make a car taller than the block unless you add a spoiler. So let me first start with a car with no spoiler. Let's take this car right here. Once again, no wheels on it, no axles, but we can use this as a good example. Remember, we're not talking about airfoils, we're talking about the car body. So if I were to measure from the lowest point of the car body to the highest part of the car body, which typically is going to be in the back of the car, let me go ahead and measure this. I'm going to zoom in a little bit closer here so we all can see what's happening. If I were to measure this height from the lowest point to the highest point, you can clearly see that this car is at least almost 40 millimeters. So this is, for a car body, this is a legal car body. It cannot exceed 50 millimeters in height. Now the only way that would happen is if a student were to add something to the top of their car. For example, the student added an optional part called a spoiler. This is optional. This is something we'll talk about in just a moment here. But if I were to measure to the lowest point of the car body, to the highest point of the car body, and the top of the spoiler, this cannot be taller than 50 millimeters. I've measured this one multiple times, and I know for a fact that this car here has a minimum height of, maybe 44, 45 millimeters. So this, even with the spoiler, this car is legal. They could have had the spoiler higher, but once again, you cannot exceed 50 millimeters overall with a spoiler included. The spec that says overall body width, kind of like what we talked about here. These two numbers are very much talking about the same thing, but this is probably why I included this spec. Students do like to make internal cuts, not many, but some. So here's an example of an internal cut. This is a car I made last semester. Top view, you can see I've extracted some material from the inside of the car body. We have to be very careful here. Let me kind of zoom in to this part of my car. Even though I removed material from the inside of the car body, I left some thickness here. And if I make these walls too thin, I risk having the car break during construction. So the spec states that if you do want to make an internal cut, which means extract material from the inside of a car body in this case, these walls here should be no thinner than 7 millimeters. Now keep in mind, as you construct, things will get thinner, which can happen because we can incorporate the tolerance, but we're not worrying about a tolerance yet with our working drawing. So not many kids make internal cuts. It's more time, it's more work, but yes, it can make a car lighter. Okay, so let's now jump over to the next piece. Let's talk about axles. The axle holes that we're going to be drilling, we're going to use a drill bit of that diameter. But this is the spec I want you to look at. There's no minimum or maximum distance between your wheels. That's kind of a nice thing because it's something you just don't have to be worried about when you're figuring out where to place your wheels. Now, do you have to think about the location? Of course you do. The front one, you have a lot of flexibility. The back one, you need to be a little bit more conscious of the following. Keep in mind that there's no minimum or maximum distance. You can put these wheels as close or as far apart as you want, but I want you to think a little bit about the rear axle. Here's a CO2 cartridge. We're going to place this inside your car on race day, so that's going to go inside the car. I want you to understand that this cartridge is sitting inside the car body. That being said, this is a lot of weight. So when we put this cartridge in the car body, a lot of that weight is going to basically kind of create a seesaw effect on your car, meaning it's going to want to drop the back of the car with all this weight like so if you put this wheel too far back. So here's something I want you to be thinking of. It'll also be in my video. On my technical drawing, which I'm sure many of you will be printing this paper, this area here is where the cartridge is going to go inside your car, and this is called the safety zone thickness. We're going to be talking about that next. I typically suggest, not require, but suggest that you put your rear wheel somewhere under the CO2 cartridge area. Somewhere in the back of your car, under the CO2 cartridge housing, that's where you want to put your rear wheel. If your rear wheel is too far forward, the moment we put all this weight in, there's no support underneath it, your car is going to want to teeter-totter just a little bit like a seesaw. So be thinking about rear wheel location in relation to the CO2 cartridge hole that we're going to be drilling. Now, another thing we have in our specifications with the axles is the distance that the axle hole is going to be drilled. I made that very easy for you. Once again, on this piece of paper that many of you will be printing, I have created what's called an axle line. That little dotted line is where you're going to be placing a center line to tell me where you're going to drill your axle holes. Keep in mind that the distance from the bottom of the block to the axle location, this is already 9 millimeters. Your axle hole cannot be lower or higher. It has to be exactly 9 from the bottom of the block. So if I were to look at this design right here, keep in mind whenever we measure this distance, it's from the bottom of the block to the dead center of the axle hole should be 9 millimeters. From bottom of block to center of axle hole, 9 millimeters. Okay? Now, let's go ahead and jump into the CO2 cartridge housing. This is a spec that should sound very familiar from your CO2 dragster car project that you did in level 1. Minimum thickness says 5, but after construction you can make this part of your car thinner, down to 3. So let's just take a look at this car here as an example. This is about safety, this thickness here. So on race day we're going to be placing this 8-gram CO2 cartridge in the back of your car. When that seal, which you can see has been punctured, when we do puncture that seal, it's going to push this cartridge forward with a lot of force, which in turn is going to push your car down the track, 50 feet of track, in hopefully 0.9 seconds or less. There's enough force when we puncture that seal that that cartridge could crack through the car body if it's too thin. So the specification reads, your CO2 cartridge housing should be at least 5 on the drawing, which is why I shaded this in for you. This is a 5 millimeter shaded in area. You cannot draw into that area. You can draw up to it, but not into the shaded area. But after construction, you can start to remove more material around the CO2 cartridge housing, and you can make it as thin as 3. Now, even with this specification, there is no tolerance, meaning you cannot make it less than 3. The tolerance is 1 millimeter, which means, sure, someone would think you could then end up with a 2 millimeter thickness. There's no tolerance for this part of your project. So, that being said, if I were to measure the final product, this final product happens to be just about 3, maybe 4 millimeters. So once again, after construction, it can be less than 5. But on your drawing, it will be 5 or more. If we take a look at this car here, the student clearly has a thicker CO2 cartridge housing. And if I measure all the way around, that's about 6. That looks like that's a little bit thinner. That's closer to 5. That's fine. You can make this thicker than 5 millimeters. What you then come into is the fact that you're making a slightly heavier car. This is a part of a project that I think students over the years have done a much better job reducing mass. It's around the CO2 cartridge housing. Now, it's your car. You can do what you want to do, but I highly suggest students consider extracting. Look at this design here. That is 3 millimeters, all said and done. Once again, it can be no thinner than that after construction, but we're going to draw it to 5. This is where we tend to find a lot of mass left on cars, which we can still reduce. So consider that in the construction process. So let's now talk about what I refer to as the parts. We have a spoiler, clearly says optional, front and rear airfoil, and side pod. Okay? These parts here, they're all separate from each other. They each have their own set of specifications. Let's start actually with the spoiler. Even though it's optional, let's go ahead and start here. So what does the spoiler do on your project? Well, the reality is not much. It's more for aesthetics, appearances. Separate your car in terms of looks. But on a real Formula One car, this would actually create some turbulent air, and it would also create a downward force to help push the wheels closer to the track to give the car better traction. This, once again, on your project is more for looks than it is for performance, which is why it's completely optional. Not many students do this, but I give them the option to do it. Here are the specs for a spoiler. It can have a minimum, remember there's minimum. Minimum just means at least that number. A minimum length of 20, a minimum width of 62, and a minimum thickness of 3. Okay? Now, let's start with 20. So keep in mind that this car has been constructed, so this is length. Length is left to right in this case. So if I were to take my ruler, I wouldn't be surprised if this is slightly less than 20, simply because this car has already been built. So there is now a tolerance that can be applied to a completed project. So if you look at this car here, you can actually see that this car is just under 20 millimeters, which is legal for a completed car that's been constructed. It's probably closer to 19, but the length of this on your drawing should be a minimum of 20. Thickness is 3, so that's now measuring in this direction. Okay, I typically tell kids just find the thickest part of your spoiler, and that area should be at least 3 millimeters. This one actually looks like it's closer to 5, so they actually could have made this thinner had they wanted to. And trust me, it's still going to be structurally, it's going to be fine. It won't snap or break if you handle it with care. And this is now what we refer to as the width, 62. So the width is the overall width of the part. And if I measure from edge to edge, this should be at least 62. And this happens to be exactly 62. Okay, so this one is legal as well. So that's a legal spoiler. Once again, optional part. Let's now talk about some required parts. Airfoils, and I have this small little picture here underneath it. Now we've covered in slideshows and through class collaborate sessions what these parts do. And it's all about redirecting airflow. You could have a convex part, a concave part, and it's all about redirecting airflow. Size, shape are very critical here. So let's start with the length is a minimum of 25 millimeters overall. Width, once again, at least 62. And the height should be at least 15. Okay, let's take a look at a airfoil on a car. And actually, we can go ahead and take a look at this one right here. That's a rear airfoil, and that's a front airfoil. Okay, so when you're measuring these parts, you want to take the overall length. So from here to here, this is the overall length of the part, meaning I wouldn't start measuring from here, because there's a part that even extends further out. So from here to here, this needs to be at least 25 millimeters. So if I were to measure this part here, overall, remember I'm measuring to the furthest part to the left to the furthest part on the right. This student clearly has a part that's legal. It's at least 25. It's actually close to 40 millimeters. They could have made this shorter had they chosen to do so. The height needs to be at least 15, which is the bottom to the highest part. Okay, that right there is what I'm going to measure. So I'm going to use my ruler vertically, and I'm going to measure it, and I'm getting about 25 millimeters. Once again, 15 is the minimum. So this could have actually ended up being smaller had the student decided to do it like that. Here's another example of an airfoil. This is another front airfoil. So once again, we measure the furthest to the left to the furthest on the right. That is your length. Height is the lowest to the highest point. Okay. Here's a rear airfoil. And here's a very unique airfoil. And I want to point something out. You can have an airfoil that extends beyond the car body. You can even have an airfoil that falls a little bit behind the front of your car body. So there are different ways to approach these airfoils, how they're attached and where they're located. You can see this is a very unique design here with the airfoil in relation to the car body. Okay, so once again, minimum length is 25, minimum height is 15. Width, once again, applies. And here's how we measure this one. This is, once again, kind of like the spoiler, but because these were glued on both sides of the car body, I still measure the overall length, or excuse me, width. So it's from here to here. This should be a bare minimum of 62, and this is coming in at just about 62, maybe slightly over, which once again means it's legal. Okay, so you're going to have a front airfoil, a rear airfoil. You might focus on a convex design. You might focus on something that's a little bit more concave. Once again, you're redirecting the air so the air goes over the wheels. continues moving over the side pod and rolls off the back of your car. Okay? On a fully assembled car like this one here, something we'll get back to in just a minute, is this gap here and this gap here between the wheels and the parts. This is a very important space that we're going to talk about in just a moment. So let's now finish with the side pod before we get to our last part, which is going to be the wheels. Side pods also have their own specifications, and I actually have changed this over the years so students can make lighter cars. The length of a side pod is 50 millimeters minimum. The width is 62. We see that number come up a lot. In the front view, it can have a minimum thickness of 10. You can also refer to that as height. And same in the top view. Okay, I'm going to be getting into this next. So let's take a look at, let's look at this blue car again. This is a nice looking car. So once again, let's talk about length. Length is at least 50. So you need to measure the extremes. Furthest point to the left to the furthest point to the right. That would be the length. Now keep in mind these 2 points here, they're further inward. So I'm taking the overall to the overall. So I can clearly tell that this is a legal side pod. This one's actually coming in close to about 60, maybe 66, maybe 67 millimeters in length. So it's a fairly long side pod. It could have been shorter, but the bare minimum is 50. The height or thickness refers to this. When you take a look at a side pod, you want to find where's the thinnest part. That's the thinnest part of this side pod right here. So I'm going to take a ruler and measure this vertically. According to my specs, this needs to be at least 10 millimeters, and you can clearly see that this is at least 10. It's probably about 11, maybe 12 millimeters, so that is a legal side pod. So once again, minimum 50 in length, minimum 10 millimeters in thickness in the front view. Now, when we look at this from above, there's this other thickness, top view, 10. And once again, we have this thing called width. So when we measure width, I always tell students that, take a side pod for example, they flared it in, but then they came back out again. You need to have parts of these side pods, even your airfoils. You'll notice they're narrow here, but they taper outward. This should be at least 62. This should be at least 62. It's okay that you came in. It's okay that you tapered in. But the widest part should be at least 62. So if I take a look at this side pod and I measure from one side to the other, once again from here to here should be at least 62. So the question then is what does this mean? What does this thickness 10 top view mean? Since students like to curve or flare in, which is totally acceptable, you'll notice that it's wide, wide, thin, thin, thin. The thinnest part is right here. It's right where it gets glued. That's the edge of the car body. Where this got glued to the car body, this needs to be at least 10 millimeters here. So if I measure this right here, now this student is coming in just under 10 because they now have a tolerance. So that actually is legal for a completely constructed, painted car. They're close to 10, but they're probably just under 10. So your drawing, this can be no thinner than 10 if you decide to curve or taper or angle in. But a final car can be 1 millimeter less than 10 because we have a tolerance of 1. But this is 10 millimeters min on your working drawing. Okay? Last one we'll talk about are the wheels. Now this is going to be challenging to draw. Unless you have a compass, this is going to be challenging. So wheels are 34 millimeters in diameter. Keep in mind this is not a true wheel size on this paper. Okay? So a true wheel has a diameter of 3. The width refers to this part of the wheel to the furthest point outward. That distance between my two fingers is 19. We're not going to worry too much about that right now. The biggest piece here is the diameter is 34. Okay? I'm going to recommend if you don't have a compass that you attempt to take a ruler, plot a few points, get the correct diameter, which is 34, which we know the radius would then be 17. But I want you to attempt to draw as circular as possible a set of wheels. It's going to be a little challenging, but just do your best, and I will have that more likely in my video. Last part is this thing called the wheel well. Okay, this is a very big deal, so let me go ahead and show you a car that's not assembled. Here's what the wheel well is. The wheel well is the distance between the parts. So there's going to be a wheel that's going to be sitting somewhere in this gap, and you can clearly see here, if I didn't drill this axle hole correctly, I could have a wheel touching a part, and that's definitely something I don't want to do. So we got to make sure that this opening is a bare minimum of 40 millimeters. We call that the wheel well. So I'm going to go ahead and place this here. I'm going to go ahead and take my ruler, and here's how I'm going to place it. I'm actually going to place it just like this. Okay, I want you to take note of a few things. First of all, the distance from the inside of this part to the inside of this part is 40, and the center is at 20, which is actually where I drilled the hole for my axle. That's a very common thing students will do. They'll make the wheel well exactly 40. That's the distance between your airfoils and your side pod, and they'll put the wheel dead center at 20. Okay, now you could have this gap larger, meaning you could have your parts further apart if you so choose. That's okay, but do not put them any closer together, because by doing that you're going to have this wheel touching apart. Okay, so the bare minimum, as it says on my spec sheet, the wheel well, that's that opening, should be at least 40 millimeters. Now, you do risk having too big of a gap. I'm not saying that this is incorrect on this design, but if you were to push the wheels further away and open up this space between the wheel and the part, air could be redirected, but if there's too big of an opening, it could actually get caught inside that gap and create some turbulence in here, okay, which in turn is going to increase some fluid friction. So we don't want this gap to be too big for that reason, and if it's too small, the wheel could touch the parts. So we don't want to have any what we would refer to as surface friction, wheels rubbing against parts as they spin and move down the track. Okay folks, I'm going to stop right there. Once again, I want to remind you that this video was recorded to give you a better look at the specifications. It wouldn't be a bad idea to have this video on the ready if there's something you're not clear about after I discuss this in my Collaborate session. So this is going to be posted obviously on YouTube. You want this piece of paper, you don't have to print it, you can just have access to it. As you go through your working drawing, keep in mind we'll have posted this document in Google Classroom for you to print, and if you don't have a printer, you can definitely use notebook paper or graph paper. It's going to be a challenge, but try to draw something as accurately as possible using either a ruler of your own or you can print this metric ruler and make this as precise as you can. I'm going to stop here. Good luck with your drawing.